positive.
I just said, oh, that was so good, I need a moment.
Oh my God.
Nate's laughing.
Oh Lord.
Okay, questions, I'll come around. Okay, once you got the values now, draw a conclusion. What does the question on the bottom says? What are you now discovering about the magnitude of the moment due to a couple? So look at the values you got for the moments, and what did you learn? Okay, what did the moment of A turn out to be? Say it again?
Negative 100 foot-pounds.
Negative 100 foot-pounds.
Negative 100
And what did you get for a moment of B? Negative 100 foot-pounds. How about for D?
Negative 100
Negative
Pound
100
foots.
foot-pounds.
pounds. Sounds better, man. I like that.
Okay, so what did you discover? Two things. Well, actually, maybe you could even say three. So what did you discover?
As long as the couples are in the same spot, they'll have the same. It'll give you the same moment.
Okay,
Anywhere,
so
right?
not that they're in the same spot, right? Because they're not in the same
Well, no,
spot.
not what I meant, but like if
Because,
you keep them.
wait, let's just use the right words.
Yeah, yeah.
Because if they were in the same spot,
Right.
if one was going up 550 and one was going down 50 in the same spot, they would be concurrent, and there would be, what would the moment be? Zero, because they cancel each other out. Right? Okay, so let's say the words again.
Okay. As long as they're fixed at the two same point, not the same point, but that's why I'm not an English major. But
Okay, so let's, that's why we all are. Okay, so let's just use the word couple, because we already know in our mind that a couple is two forces, opposite in direction, right?
right,
And, but same magnitude, right?
right.
So just use, whenever we have a couple,
Okay.
what did you learn?
We have the same moment. Whenever we have a couple, we have the same.
Whenever we have a couple, the moment at any point in the system is the same.
That's what I was gonna say.
Okay, good. And we have to add something to it. So what I wrote is, whenever we have a couple, the moment at any point in the system is the same. But I have to say something. I have to add one word in here. It's important. Jose, are you thinking of that? Because let's say I had another force here. If I had another single force here, would the moment have been the same? No. So whenever we only have a couple or couples, we can't have any singles. Jose first and then Eugene.
I was just going to say when finding one moment.
Okay, hang on a sec before we go on to that.
Does it
Eugene, you have a
matter the
question?
distance?
Say it again?
Does it matter the distance?
It doesn't matter the distance, but there has to be a distance, right? A 50-pound force up and a 50-pound force down is not a couple. There has to be a distance between. So maybe we should add that. Two
That's right.
forces equal in magnitude, opposite in direction, spaced apart.
I was going to say something like that.
Okay.
Two non-concurrent
Otherwise, it would be zero. The force and the moment would be zero. Yeah, it would be, sure. Okay, question, or are we going to make another statement?
Yeah, I was gonna
Question?
ask a question.
Yeah.
If you have a couple and they are both, okay, so they're always equal in magnitude.
Yeah,
so,
even if they're diagonal.
okay,
yeah,
are you
even if
gonna
the
get moments that are twice as much as the force.
Well, what did okay, so that's getting into our next comment. Jose, what did you want to add?
Oh, that, when finding the moment for the radius is just the distance between the two.
Right, so the magnitude of the moment due to the couple is the magnitude of the force times the perpendicular distance between the forces. So it turned out to be double just because the distance between was 2 feet. But the magnitude of the moment is the force of 50 times the perpendicular distance between, which is 2. But this is just the magnitude, right?
Yes.
So now a third comment is going to be about the direction. And for the direction, we use the right-hand rule. So let's look at this.
What does that say? Times
Sorry.
the perpendicular
Yeah,
distance.
times the magnitude of the force times the perpendicular distance between, the forces. So let's do this. Remember, we're looking at a two-dimensional thing, right? We're looking at an XY plane. So what's sticking out at us? The z-axis, right? Does this create... So we have two forces here, and they're in the XY plane, so the spin has to be about which axis? Z. Does this create a positive or a negative spin? Do this. Make it a circle. Is it positive or negative?
Negative.
Negative. What's this one? Positive. What's this? Negative. What's that one? Positive. Positive or negative? You getting it?
See.
You're just looking at how it spins. Just put your hand in the direction it's spinning. Spinning like this. Spinning like this. Spinning like this. I want that one. Negative. Sam?
If you were rotating about a point in between the couple, would you get a different magnitude?
Okay, say that again.
If you were rotating about a point between the couple?
Oh, if I tried to find, like if I have this 50-pound, oh, let's just do it on the drawing. You mean if I was trying to find the moment about this point?
Yeah.
Is that what you're saying? What do you think? So let's do it. Let's pick this point as point E. The moment about point E is equal to 51 on the left times 1 negative minus 50 times 1. It comes out to be a minus 100 foot-pound. So we're proving, your question just proved this once again, that whenever you only have a couple or couples, the moment at any point in the system is still going to be the same. So this whole bar here is spinning a negative 100. It's spinning like this towards me. Well, actually, I shouldn't say that. That was wrong, what I just said. I said it's spinning like this, which is correct, but I said towards me. Is it moving translationally? No, right? Because if you sum up the forces, what does the sum of the forces turn out to be? Sum of the forces? You got 50 up and 50 down. The sum of the forces is 0. There is no translational motion at all. There's only a rotation.
What is she spinning?
So it's only spinning, so it's not spinning towards me, it's spinning right in place, it's not going anywhere. I'm glad you asked that question. Does everybody get that? Because if you did some of the forces in the Y, it would turn out to be 0. There's no translational motion, it's only rotating. So when I have, if I had a large bolt and, you know, I put my Phillips screwdriver in there, couldn't I just have done this? And you do that, right? When you're trying to loosen a bolt or tighten a bolt, don't you first use your hands? I tend to use my hands first. See if I can, let you know, lefty-loosey, right? Turn it that way, is that positive turn or negative? A positive turn loosens it, right? Lefty-loosey, turning it to the left loosens it, turning to the right. I typically go to it with my hands first and see if I could do it. And when I apply a load like this, aren't I putting a load on one side and a load on, I'm actually applying a couple. Right? Force and equal distance. I go like this, right? You turn a bolt, you're really putting on there a couple. Otherwise, I could just take the screwdriver and stick it in and apply the moment directly. Right? Everybody seems quiet. Should you get up? This is a great realization, isn't it? I don't see any smiles or anything.
No
Stand
way.
up. Stand up.
I'm a game face on joint.
Come on. Stretch. So you're applying a couple when you go to